So hi guys and welcome to the Spotlight. Welcome to Geek News. Press the subscribe button and that bell icon also. So in this video we're going to be talking about two things. The launch of the Falcon Heavy and the image of the black hole. I know that I've already made a pretty long video on Falcon Heavy, but this is post-launch fever. Well, by the way, have you seen this meme? Well, let's first start with Falcon Heavy launch and the incredible and unprecedented landing of all the three boosters. They even landed the center core, which they had failed last time. And of course, they recovered fairing. This was not simply recovering them from the ocean. They had avionics, steerable parachutes, and nitrogen thrusters, which could guide them safely. And I forgot to mention the hype in which I was. Since the first launch window, I used to get up at 4 AM IST every day just to watch the launch, only to find that it was postponed. Only Indians will understand this. It was like the counter close thing, which happens when you go to a government office. But then it finally happened, and SpaceX recovered all the three boosters. And in an astounding achievement, the fairings too. And these will be used on a Starlink mission later this year. Which means the whole rocket will be reused except the second stage. SpaceX was awarded a launch contract by NASA literally minutes before the Falcons had landed. Get over here! It was for the DART mission, which is essentially a mission that ensures our survival so that we don't go extinct, as the dinosaurs did when an asteroid hit Earth. Yes, NASA is actually planning for a sci-fi scenario. NASA is planning to send a probe towards an asteroid Didymos's moon. They'll target that space rock, which is potentially not harmful now, but just to prepare for a future scenario. When the probe strikes the space rock, they'll monitor the trajectory change to know whether the plan is viable or not, and then use it against the asteroid. The Poway, the image of the black hole at the center of Milky Way, which is Sagittarius A, in a faraway galaxy M87. It was the first time a black hole had been observed directly. Till now, every single image of it was a simulation or a render. So let me first tell you why it was so difficult. It was like looking at the time of a wristwatch kept at moon. Sounds easy, right? And according to some law of lensing, you would actually need a telescope the size of the Earth to do that, which is quite impractical, right? But then slick humans decided to connect telescopes from all around the world to observe just this one thing, actually two things, two black holes, right? And then compile the data together to get an image. All the data from all the telescopes was compiled in Massachusetts. It had to be flown on airplanes. It was literally that much. So now let's talk about how to look at the image of a black hole and what to infer from it. The glowy thing around the black hole is actually all the matter which is orbiting the black hole. Now, due to friction and collision between the matter, heats up to millions of degrees of Celsius, causing it to emit X-rays. Now on Earth, we can only detect black holes because of their X-rays. And while clearing the picture of a black hole, this is the part that we were focusing on. And the glowy disc-like thing is called the accretion disk. Now I'm sure that every one of you must have watched Interstellar. Remember Gargantua, the big black hole? Well, if you haven't watched Interstellar, look at this. Now surprisingly, these predictions are quite real, and the images clicked by us have a nature quite similar to the simulations done by the guys at Interstellar. First, in a nutshell, a black hole is basically a dead star which has collapsed under its own gravity into an infinitely dense point from which even light cannot escape. Now, to observe a black hole, we need light bouncing off its surface. But the gravity of a black hole is so strong that even light cannot escape from it. Precisely from a point called event horizon. It's a point of no return. Well, light reflecting off the surface of a black hole is highly unlikely, and even if it does, it gets sucked back into the black hole. Now, distance from this point, also called the point of singularity, to the event horizon is called the Schwarzschild radius. Now, at roughly 3 times this radius is the last orbit, which can be achieved by matter other than light, called the accretion disk. This is actually all we can see for a black hole. The image should look somewhat this, which looks quite similar to the interstellar one and the real one too. So, instead of looking like Saturn with all its rings, why does it look the way it looks? This is just an illusion caused by gravitational lensing, which is actually a phenomenon due to which black hole's gravity bends light and behaves as a lens. As you can see here, light is supposed to bounce off the accretion disk and head towards us, the distant us, straight. But due to the gravity of the black hole, the light from the matter facing away from us, which should bend and go in the opposite direction, bends and comes towards us, which makes the disk appear to bend over the black hole and creates the illusion and makes it look quite like the interstellar one. Well, actually it's not that way. We just think it that way.